So hello everyone, it's nice to see all of you here, and you'll be listening to my babbling for the next 40 minutes, so that's great as well. What I'll be talking to you about is the MediaProjection API and how we dished it to build something actually awesome. So yeah, I'm István Juhos. I'm a staff software engineer at Spoke, which you might or might not heard about. So let's start with the introduction. It will be brief, I promise. But yeah, what's Spoke? What are we doing? We are a last mile delivery platform, software as a service, and we provide route optimization and other software services for delivery companies and individual delivery people. We have a couple of products, a few actually. I'll highlight two of them because they will help understand the context. One is Spoke Route Planner, which is a map app that helps you optimize routes to do them as efficiently as you want. For individual drivers, this is really meaningful because if they get the most optimal route that they can take in a day, that spares them time. That's our value proposition with this product. This is our first one actually, and we built upon this context. Okay, the other thing is Spoke Dispatch, which, as I said, builds upon the success of the route planner, and this provides warehouse management and driver management and route management and so on and so forth for depot managers and teams. That's all of the products. What I actually want to talk about is how we receive and handle user feedback. To receive feedback from our drivers and from our customers, well, we can receive that via direct contact with our sales people and PMs. We maintain a Discord community with a lot of members and counting, where actually all of our PMs, even the CEO, and of course the engineers are there, and we can be contacted pretty much directly with ideas, feedback, bug reports, and so on. And of course, pretty much a standard thing, we have intercom integrated into our application, where the users can have the intercom provided screens, they can navigate to them, they can contact our support team there, and the support team will answer. Going deeper into that, we actually have a quite capable support team on the other end of intercom who triage and report issues that they receive via intercom, and actually users are using intercom chats to contact us a lot. It's a really enthusiastic bunch of people, actually, all over the world. So yeah, the support team triages things. They have playbooks to go through if they receive like regular issues or like generic issues. But if they encounter something that they can't really process, they forward that to the product people if it's a feature request, or directly to engineering, to us, if it's a bug or an issue. Actually, our support team and all of us in the company encourage our users to send us photos of their issues or any feedback, and actually, more importantly, screen recordings, because a video about an issue is worth more than a wall of text describing the issue. That's quite straightforward. And that is the point that I will be talking about for the rest of the talk, pretty much. So brace yourselves. Users can share screen recordings via many options. They have many options for this. The first, which is actually quite popular, is third-party apps. Because third-party apps have been around supporting screen recording since Android 5, which is quite an old thing now. So users choose their own screen recording application if they know there are any, if they are tech savvy enough. Because yeah, there are users who do use route planning apps but don't use the rest of the phone, and that's okay. So the support team either requests a video or the users report back by video. And it's actually the route that matters, pun intended, how they do this. So the usual flow for them is that the support team asks for a video proof or video description about an issue or a feature request. how they are doing things. So the user then goes out of the Spoke app, does something with their video recording app of choice. They start recording however they want, however they can. They go back to the Spoke app, reproduce the issue in the Spoke app. They go back to interacting with their recording app, and they go back to the Spoke app, go to intercom, and attach the file that the recording app recorded somewhere. So it's a whole lot of hoops to jump to just record and send a video. Fortunately, ever since Android 11 arrived, built-in screen recording is available. But then again, you have to go through some setup to get that available, at least on Pixel devices. So in the video, you can see that it's a quick setting tile to enable, let's say, enable the recording to make it really accessible. And then you have to start it, and then you have to do the recording. It records your whole screen, of course. And then you have to stop it, and it's saved, and so on and so forth. So again, hoops to jump through, especially when the user didn't set it up before, didn't record the video any time with that particular device. And of course, this might be different for each OEM, a Chinese OEM, Samsung phone, or a Pixel phone. So then again, support team has their job cut out for them. And we've seen this. And we've come up with an idea. Let's improve this video feedback experience. So we set out some initial goals that we should follow. The first is obviously reduce this friction that users now have for this whole process of sending us a video. It should be straightforward to do from the app and to record a video of the app, right? And also, there was another goal. I'll give you some more context on this. Our designers, UX designers, often do ride-alongs with drivers, delivery drivers. They organize a session, they hop into the truck next to the driver while the driver is using the Spoke Route Planner app, and they talk. The driver tells how they use the app, what they want differently, what workarounds they use, and so on and so forth. But for this to work, we actually have to send that designer to the driver. They have to arrange that meeting, and they have to spend a day together. With a video recording that spans the whole day, we could optimize that flow, right? The user could just record, the driver could just record their whole day of delivery sessions. They could comment on it with their voice, describing what they do, what they want differently, and so on and so forth. So this is an extra thing that we imagined, that we set as a goal for the whole recording thing. So we started researching how we could achieve this. And the obvious first thing to look for is built-in solutions. As Android already supports screen recording, we looked into how we could leverage that capability. And of course, we arrived at the MediaProjection API. It was quite straightforward. It was along the first search results, of course. So we started looking into that. It was introduced in Android 5, as most of the apps that didn't need root to operate to record the screen already were using the MediaProjection API under the hood. So there is no coincidence there. This was fine because our Min API is already 26. Actually, we implemented this feature last year, so this whole story is almost a year old that I'm telling you now. So we had Min API 23 at the time. It was okay. But, and there will be many, many buts along the way for the rest of the talk, so just prepare for that. This MediaProjection API only supports whole screen recording, at least supported whole screen recording at Android 5 up until a certain version. We will be talking about that. It has limited audio capture capabilities on Android 5, means microphone only, which would be actually okay for us. And the most concerning part is that every time you initiate a media projection session, you get this dialog. I mean, the user gets this dialog, which has a whole bunch of text the user has to read. Probably they don't, of course, and they have to explicitly press that Start Now button to start the recording. And this is a system dialog, of course, so we don't have any way of customizing it. So the thing is, this is already a first point of friction that we kind of wanted to avoid, but of course it is understandable. The user has to explicitly allow to record their screen, because at this point in the API's lifecycle, the API will record the whole screen with notifications and private info and whatever. So, of course, from a privacy standpoint, this is okay. From the UX standpoint that we were aiming for, it's definitely not. But we went further to see what is up with the MediaProjection API. We were still evaluating the things. So we dived into the history. Let's see what we can have anyway. And of course, for context, this is nice. Android 10 introduced system audio capture. Not a big thing for us. It's a big thing for general development, of course. Android 12 adds some more restrictions. A foreground service has to be started to start the recording. I mean, the recording has to be started from a foreground service. Of course, foreground services need a notification, a persistent notification to be up. They added the privacy indicators that you now possibly usually see when an app is recording in the background, the camera is rolling, whatever. And yeah, just a side note, audio capture is opt-in per app, so you can decline or deny providing your audio from your app. It doesn't really matter for our context. Android 14 added some stronger privacy. You can blur sensitive content if you opt into that. Some OEMs even added watermarking for sensitive content, whatever. Android 14 QPR2 added single app sharing. And as you can see, now we're nearing the recent Android release. So at the time we were investigating, this was, well, most of the devices, the majority of our user base. So Android 14 quarterly update 2 added single app sharing, which is closer to what we were aiming for, which is nice. But the dialog evolved. That system dialog has an extra option now the user can choose. It's a drop-down menu which defaults to share one app, which is actually not the default that it was before. So if the user just taps next when share one app is selected, which is the default, they are presented with a bottom sheet. Yay, a system bottom sheet that we have no control over. And that bottom sheet actually lists your recent apps and some more frequently used apps on the bottom as icons. The thing is, besides not having control over it, is that it's slow. Just as an example, I'm playing Pokemon Go. Some of you may be playing Pokemon Go as well. And Pokemon Go doesn't really share data with us the way we would want to. So there are screen reading apps that try to figure out things from the screen's content. And they use the MediaProjection API, most of them do. And I have quite a few apps installed on my recent hardware. And this dialog takes sometimes 1.5 seconds to just load the content on it. That's not a great UX, right? And the other thing is, even if you, the app, is the one who initiated the media projection session, the user has to select you to record you, which is kind of awkward. So if we start this flow from the spoke app, to record the spoke app, the user has to jump through the dialogues hoop, has to jump through this as well and select the spoke app. Possibly while they are driving, so please don't. It's not a good UX. So at this point, we started having doubts about doing this. A bit extra, the latest update to the MediaProjection API, Android 15's QPR1, we got an indicator chip on the top when a recording is in progress in the background. Yay, nothing really substantial there. What is substantial is this recent data that I just pulled up from the Play Store. So this is our distribution of OS versions used. I discarded everything below 1%. So the thing is, our users are still using, and a lot of our users are still using APIs, Android versions below 14, meaning hundreds of thousands. So the whole thing would be a fragmented mess, and by doing this, we just wouldn't have made the job of the support people easier. We would have just complicated it. So we arrived to some conclusions. We don't want that inconsistent UX. We don't want to burden our support people with doing this all the time and supporting this all the time. As we've seen, there are a lot of system dialogues involved, which we have no option to configure whatsoever. So the whole thing would just induce more friction in the users, and they would get frustrated. And we really didn't want that. And then we arrived to a conclusion that, well, it's time to go custom. So here we are at the point where we decided to build the custom in-app recorder. We came up with some new technical requirements. We should only record our own screens, the app's screens, and nothing else, not the status bar, not the notifications, not anything, just our screens, just our app, to improve privacy. We don't need anything else, just our app to report bugs, right? Audio capture is essential, as I said, for ride-alongs, where our users could tell what's happening on the screen actually, what their intention was, and so on and so forth. But it should be optional, voluntary. So we had to implement a way to mute the microphone during the recording and re-enable it again. If we are able, we should also show the taps the users are making, because it makes debugging much easier visually. We had to optimize video quality because, these videos are recorded on the user storage, on the phones or devices storage, and then they also have to be uploaded, possibly via spotty connections, or maybe at the end of the day when the user is in Wi-Fi range again, or not using that much battery, and so on and so forth. Side note here, obviously Work Manager was involved, but we're not talking about that now. And also we came up with UX requirement, because the whole thing has to just really be part of the application's flow. It has to be part of our UI. And we also wanted to support deep links, because if we're doing custom things that lead to flows in our app, we could do basically anything. And the idea of deep link support that directly takes the user into the app and starts the recording without them needing to do anything is, well, a good way to reduce friction. The support people in the chat could just add the deep link, and the user would instantly start recording from the main screen of the app. And as you will see in the demo at the end of the talk, sharing the video back to intercom is quite easy as well, because we thought about it. Of course, I said that we would have a built-in UI flow, which kind of looks like this, but don't look at it too much. I will show you in the demo. So with these requirements, we started figuring out the entry point in the app, in the code. We are a single activity app, we are a map app, but yeah, we are a single activity app mostly, because at that point we had some other activities. So naturally, we came to a conclusion that we could introduce the whole recording flow, the logic of the whole recording flow, in a superclass of the activity that we, actually activities that we have. So the recording capability would be added to all of the activities, so we can record the activities windows. With that, we get touch event recording as a bonus by overriding one single method. And another idea was that in those activities, in the superclass activity, we could just wrap everything in Compose we were mostly Compose anyway, but we could wrap everything in Compose and just capture the composition into a bitmap 60 times a second, and then we could draw that into a canvas and we have a video. Awesome idea. We will see. So the whole routine we put together, the idea was quite simple, and I immediately put that in quotation marks for some reason. The first part is capturing touches. That was the easiest, but essential. We capture the coordinates where the user is touching, and pretty much that's it. We feed that into the recorder, the coordinates and the timestamp, obviously. And in the video, when we are assembling the whole video file, we just render those things. Capturing audio from the microphone with the ability to pause anytime. I will go into more details on that in a second. And of course, capturing the composition into the bitmap at 60 FPS. For this overview, it's quite straightforward. For touch, okay, the touch part was the easiest. We could just override dispatch touch event in that superclass activity, get the coordinates, get the timestamp when the touch happened, and draw it on top of the combined canvas on the bitmap. That's it. For the audio, we quickly realized what we needed to do for the mute thing to happen. And what it was is just, well, when the microphone is muted, we should just feed silence into the audio stream. And well, that was the idea, and it worked. This way, we wouldn't have to actually do anything to keep the video and the audio synchronized. We're not doing the audio recording in parts. We're not stopping the recording. We are not messing up the timestamps or anything. It's just silence, 0 bytes fed into the codec. And when microphone is re-enabled, we just start feeding the microphone input again to the codec. And that was it. For the video, well, that was the most challenging part. The logic is quite simple in theory. We capture the surface of the activity window, we pixel copy everything to a bitmap, and then we render that bitmap into a canvas and write it out as a file, 60 frames per second. We should be okay. The thing is, we forgot a crucial part at this point. When we started demoing this first iteration of the app, of the recording flow, the map part of our application was recorded quite nicely. But we had dialogues. And the thing is, probably you might know it, you might not, but dialogues have a different window. Dialogues are rendered in a different window on Android, and the activity you use is the activity we were trying to record, our main activity and the other activities, but not any other window. So where we first demoed the recording feature, there was everything except dialogues. Well, we missed that. And when we have dialogues in a map app, pretty much, everything is a dialogue or a bottom sheet in a map app, and we are heavily using dialogues and bottom sheet fragments to contain composables, but still, these are different windows. Our main UI has different windows all over the place, and we forgot about those. Well, this is a moment of vulnerability because it should have been obvious, right? That if we record only one window and we have multiple, then the rest won't be rendered. The moral of the story is, well, it's okay to make mistakes. So we started replanning, and we arrived to a conclusion that there is only one thing that we could do to alleviate the situation, but still go forward with the plan, and that was reflection, unfortunately. There is an API that is not publicly accessible for every app, actually, starting with API 24, which is Window Manager Global. At the time, it was problematic. We had to branch on discovering this API because we were MinAPI 23, but now we don't even need that branch on MinAPI 26. So we fetched that Window Manager Global, and we tried to find all the root views of the window manager that is managing our app. There are differences based on API levels, but basically those are the two fields that we need. We make those accessible to make all of our rendering, all of the surfaces of our application accessible, of course, via more reflection. If we don't find this, we just default to not showing the feature at all, because there might be changes throughout OEMs, there might be changes throughout API levels. So as soon as this whole thing, any part of it is not available, we just not display the feature at all. It's not beautiful, but it's working, right? Okay, you don't have to read this. It's just there to have some code on these slides because it's just a story, but what's a coding story without code? What this code does is it just gets all the root views from one of those fields that are available on the window manager and make those available for querying and editing. It's some finding logic, a glorified for each, to say the least. Yeah, so this is pretty much the complexity. There are even some parts that I just collapsed there. But it's complex. It includes reflection, but this is what we've done. And then capturing all the frames. With that, having access to all the root views and all of their surfaces, we can iterate over them and draw them into a bitmap, which we draw into a canvas in turn. So basically, we're capturing all of our frames, all of our surfaces. We determine the layer order, and we just draw everything on top of each other. For dialogues, there is a caveat because dialogues sometimes have larger windows than they are actually rendered in. So there is some magic that's happening there. Actually, there's an API to get the screen coordinates, but let's stay at magic. And we can figure that out as well. And then we can just layer these surfaces, these pixel copies of surfaces upon each other, and then we will get the whole screen recording as a frame. And we do this 60 times a second, and we get a video. That's awesome. But to not show you all of this complexity happening here in this, again, glorified for each, we'll just stay at drawing the effing owl. And that is fine. So we got it working. Video recording was working. We were capturing all of the dialogues, all of the bottom sheets, and everything happening on our screen without the system UI, without anything else, just our app's screen. And nothing else. But we were far from done. And there were funny moments, and by funny, I mean painful. But yeah, I'll show you some issues that we encountered. Just a couple of them. There are much more. We could be here for another 20-ish minutes to go through them. So here are just some nice things that we could talk about. The first issue, the video encoder is super picky about the resolution of the video feed that you feed it. The story behind this is that we were done doing this recording part. We were happy because on recent devices, on our developer devices, which are mostly Samsung and Pixels, everything was fine. The recording came out nice, and we thought that it's okay, everything's nice. Then we published it in the company, test it. And feedback came back from our colleagues, like, the video is black. It's like, what's happening? Everything works, right? Video was black. As it turns out, that colleague had an older Motorola phone with some messed up display resolution, and we were recording the video in the display resolution. We just fetched the display resolution, set the video resolution to that, and started rendering. As it turns out, the video encoder Android provides is really picky about the resolution, and the resolution's dimensions should be a power of 2. So what we did here is we had to do some maths, how to round the actual resolution up or down to the closest power of 2 resolution, accepting the fact that we might get letterboxing as a result, which is fine. How we did it is that we looked at AOSP, and it turns out the built-in screen recording, the media projection API part, and the processing part of that does exactly the same. So we could just copy some ideas from AOSP. Sometimes it's good to look at AOSP code, it turns out. Well, even if it's complex. And mind you, we did this without AI back then, with our eyes. Like, wow. Okay, let's move on to the second issue. Syncing video and audio. There are quite exotic issues with video and audio sync. First that we encountered was video was super long, 5 hours, even though the recording session itself took a couple of minutes. We will see how this was resolved. Audio speed was faster than video on playback. So something was off with the recording synchronization. Audio was working, but the video was totally black. That, as it turned out, was pretty much the issue of the dimensions. Or different behaviors across devices and SDK levels. Of course, just some regular Android fragmentation there. We had to do some ifs and elses. The culprit of most of this was the property called presentation time micros, which is a timestamp in microseconds that we have to feed the codec with every media block that we provide them, with every block of data that we provide them. And for some parts, we had to calculate this manually, and some parts, the system gave this to us. While if we encountered software encoding devices, meaning that they don't have hardware encoding enabled or they don't have the hardware to do it, we had to manually track this presentation time micros ourselves, calculate it like you've seen on the previous slide, and feed it to the encoder. Hardware encoding enabled devices do this automatically, and we were happy about that. And the fourth issue, which is actually the third, I just forgot to edit the slides, is ending the streams. You might guess there was a third issue somewhere around there, but we have time constraints. So the third issue is closing the streams, ending the streams when we want to start recording and start encoding. For audio, in all cases, we have to manually queue the end of the stream flag, which means we feed the codec 0 bytes and the flag that this should be the end of your processing. Do whatever you need to close up the stream and close up the stream. For video, we found out there is this API, signal end of input stream, and we were really, really happy about that. And then Android came along. It turns out it only works with hardware encoding. And even though you can call that API on software encoding only enabled devices, you still have to manually do the queuing. Again, finding this out took many, many hours and many tries, and some AOSP reading as well. So how this looks like is actually quite straightforward when you know what to do. This is all the things, and there is that. Okay, so there is that flag that you have to send along with the last of the data brackets, which could be null. And that was it. And the last bonus issue that I want to show you is reading audio without the microphone recording permission, which in optimal situations shouldn't happen. You should guard everything with the permission, but there might be some edge cases where you actually start recording without the permission. The user dismisses the dialogue, presses no, but then enables it and then disables it in the background, and so on and so forth. As you know, this whole recording thing is an ongoing thing, and the user could revoke the audio permission at any time, even while recording. Speaking of which, a little side note, of course, when the user switches out from our app while the recording is still going, we just render black screen so that everything else is not recorded on the user's device, just our app. Side note end. Let's return to audio recording. So standard audio recording setup, we want to read from the microphone hardware. We can do this in a while loop, possibly, read the bytes, and then write it out with the encoder. And the thing is, if you call this audio record.read, that tries to reach the hardware. But if it doesn't have a permission to read from the hardware, it reads nothing, but it does read. So it reads, well, yeah, nothing. Not the big N nothing, but nothing. And it does it as fast as it can. It's a blocking call. That's why we do it on a background thread, of course, but it is a blocking call. So if it doesn't read anything, it just iterates over and over and over and over as fast as the CPU can do it, which is not optimal. And this is how we ended up with really, really long files, because around this logic was also the incrementation of the presentation time micros, which in turn the whole pipeline translates to the length of one of the streams. And if one of the streams is really long, even though the other stream, meaning audio and video, is not that long, the whole file will be big, a long recording with mostly nothing in it. That's not optimal either. And of course, it doesn't consume zero storage, because there is quote-unquote data there. Okay, so that was all of the issues. I wanted to show you, because we're out of time anyway. So the whole conclusion is debugging this whole thing, debugging, recording, codecs, muxers, and whatnot, is hard. We bumped into many obstacles that we had to either solve, work around, and so on and so forth. It's hard to understand. We had to read AOSP code. We had to go through a lot of things while we were getting this right. Some final concerns: file size. Because file size is important, because we have to upload this thing, we have to store this thing, these videos on the device, and so on and so forth. So we had to balance between the refresh rate. We wouldn't allow 120 Hertz, right? Because whatever, there are devices supporting that even more now, but why would we do that? And we have to optimize for resolution as well, because of course we want a crisp recording, but we don't really want on the big file size. So this is all a balancing act. And a fun fact, before I do the quick demo, it turns out it was helpful internally. It wasn't the goal, but after we released this feature, people internally, designers, PMs, whoever, started using it to report feedback to engineering with their findings in the app, bugs and whatnot. So that was a nice addition. And now just a quick demo. We have time for that. Okay. Okay, we do have time for that, right? Okay, so this is our app. We have a route here set up previously. And yeah, I could just start navigation to a stop. And this is how our navigation UI looks like. It's a nice bordering around the app. And what designers did is to frame the app in any case. By the way, this is the entry point to the feature, the recording feature, quite straightforward. Users are used to tapping that question mark a lot, because that's the entry point for intercom. We added another menu there, share feedback. We get this dialog that they will start, a bottom sheet, that they will start recording. Of course, we can start recording. This is where we ask for microphone permissions when permissions are not granted. As you can see, recording is already going there. There is a stop button, and there is the microphone input, which we have a really nice wiggly line equalizer there. Nice. We can disable that, and now it's not recording audio, but the video is still going, and that's it. So it's not intrusive. It's there. The whole app experience is still the same. We just have a framing around it. And when we stop the recording, we get to this UI. At this point, the whole video is either already encoded and already saved on the device, or it buffers a bit, but it's quite quick. We can restart the recording, we can play it back with audio as well, so we can see it there, it's happening. And yeah, we can add some details if the user wants to write something. And then we can just tap upload recording, like this, and we get a link that can be shared, or we have an instant button to share it into a new intercom chat with the text inputted. And that was it. That's our whole recording flow. And if that's done, the user can go back to their regular routine. And that was all from me. Thank you very much for listening. Sorry that I ran off time, but yeah, that's it. Thank you.